We're going to take a look at the series, the summation from 1 to infinity, natural log of n divided by n plus 1. First, we'll perform the test for divergence by taking a look at the limit as n goes to infinity of natural log of n over n plus 1. And we can write this as natural log of the limit n approaches infinity n over n plus 1. Now that limit inside the log, that goes to 1, so this approaches ln of 1, which is 0. When the test for divergence limit is 0, test for divergence is inconclusive and we have to try some other method. Now the only thing we can really try here is to go back to the definition of what an infinite series is. So we start with a sequence an, and the series is defined like this. We'll take our sequence and add all the terms. So this is a1 plus a2 plus a3 plus a4 and so on. But adding up an infinite number of numbers needs to be defined as well. And the way we define that is we form a new sequence. I'm going to use an index here called capital N, S sub n, from big N going from 1 to infinity. That sequence is called a sequence of nth partial sums. It is the sum of the first n terms of the series. So this is summation little n equals 1 to big N an. So that's a1 plus a2 plus a3 and so on up to the big nth term. And then the series is defined as the limit of this sequence of nth partial sums as big N goes to infinity. If this limit is defined, the series converges to whatever that limit is. If the limit is not defined, we say the series diverges. The problem is that in practice it's very difficult to express Sn in a form where the limit can be computed. But in this case we can do it. So let's look at our series, which was n equals 1 to infinity natural log of n over n plus 1. So Sn is equal to the sum of the first n terms of this series. So this is little n equals 1 to big N of natural log of n divided by n plus 1. And let's expand this. So plugging in n equals 1, this is ln of a half plus ln of 2/3 plus ln of 3 over 4 and so on. And then when little n is, say, n minus 2, this is ln of big N minus 2 over big N minus 1 plus when little n equals to big N minus 1, that would be ln of n minus 1 over n, and finally ln of n divided by n plus 1. Well, all we have to do is remember the basic properties of log. Ln of 1/2 is ln of 1 minus ln of 2, plus ln of 2/3 is ln of 2 minus ln of 3, plus ln of 3 minus ln of 4, plus, and so on. We keep going, so we'll notice a pattern. And then this is ln of n minus 2 minus ln of n minus 1, plus ln of n minus 1 minus ln of n, and then plus ln of n minus ln of n plus 1. So here's ln of 2 and minus ln of 2 minus ln of 3 and ln of 3 and so on. All the terms cancel in between except for 2. Ln of 1 here, which is 0, and then here minus ln of n plus 1. So we have found a formula for Sn. Sn is equal to minus natural log of n plus 1. And therefore now we can say that our series, the summation, from n equals 1 to infinity of natural log of n divided by n plus 1 is equal to the limit as big N goes to infinity of minus ln of n plus 1. Now this limit goes to minus infinity because as n gets larger and larger, so does ln, and then the minus in front takes it to minus infinity. This is not a finite number, so our conclusion is that the series diverges. That is, the series summation from 1 to infinity natural log of n divided by n plus 1 diverges. For more videos, visit www.mathprepvideos.com.